Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam Harris.
And I'm Kim Montague.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and about reasoning, creating and using mental relationships. Y'all, we take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keep students from being the mathematicians they can be. And let's be clear, probably teachers too. We answer the question, if not algorithms and step-by-step procedures, then what?
If you've been around for a little while, you know that we absolutely love problem strings as a really great routine.
Favorite.
Definitely favorite. But there are other things that we love so much.
Yeah, we've got some other favorite routines that we really like that we have sort of got from other people, and we've kind of tweaked them, made them our own, that we like to use not near as often as problem strings, but for sure as definitely instructional routines that can happen in the classroom to help students really reason and stop from just knee-jerk performing steps, because we want students thinking, looking to the numbers first, letting the numbers influence the way they choose to solve a strategy, not just knee-jerk reactions. So when we started working together, Kim, a long time ago, and I started working with the teachers in my kids' district, you were one of those teachers, and we found this routine in the book, 10-Minute Math, and we sort of tweaked it a little bit, and we've kind of made it our own, but we thank 10-Minute Math for the good work that those folks did to give us the inspiration. And we call it As Close as It Gets. All right. So As Close as It Gets is an instructional routine. It means that we want to do it often enough that it sort of becomes routine. And the purpose is to help students think, let the numbers influence what they do, but without just knee-jerk, I must compute. For example, Kim, let me just give you what I did as a student. Whenever I was asked to estimate or to round off an answer, I never did anything except do the steps of the algorithm, get the right answer, and then round it off. And then say, and then do an approximation and then say, yes, my approximation is reasonable.
Yep.
and it was so purposeless for me. I was like, why am I doing this? Like, I'm just going to solve the problem.
Yeah.
Because I didn't own anything else. You're laughing because Kim never would have done that.
It's a real thing.
I mean, it was totally real.
I've seen students do that. Yeah.
And I was so frustrated. I was like, really, why are we doing this? This is the dumbest question ever. Just tell me to solve the problem. I'll just do the thing. I'll just do the steps, get the answer. Yep. So instead of that, what kinds of questions could we ask so that kids can't have that reaction, that we actually get them thinking and reasoning?
Yeah. So let's give some examples.
All right.
I'm going to give you some examples so that you can share your thinking about how you decide which was the correct as close as it gets. What solution would you give? All right. So here's your first example. You ready? You can write this down?
Yes. Okay, go.
So you have your pen. I know.
I do, actually.
And I have a pencil.
Right next to me.
Okay. So your first question is 4/5 times 10/9.
Okay, 4/5 times 10/9 is
right.
the question.
It's the question. Okay, so let me give you your choices.
Okay. So it's like a multiple choice question.
Yep.
Okay.
And you're not solving, you're thinking.
Yep. Okay.
So 0.
Okay.
0.5 or half. 1 or 2.
So I can only choose those 4 choices. I can't,
Correct.
like if I work out the problem, that's not, I don't have to do that because I'm looking for the answer that's as close to the correct answer. Yeah, cool. And it's not about rounding or estimating. It's about me like making sense of the problem. All right. Let's see. 4/5 of 10 ninths. 4/5 of 10 ninths. 4/5 feels like almost 1, a little bit less than 1. So I want almost 1 of 10 ninths. 10 ninths is a little bit more than 1. So I want almost all of a little bit more than 1. So to me, that sounds very much like 1. So I'm choosing 1 as my strategy.
Nicely done.
Or as my answer, and that was my strategy. Cool.
Yeah.
Would you think about it any other way? I'm curious.
Yeah, I like percents, and so when I see
Yeah.
4/5, I just know 80%. So I would think 80% of a little more than 1, and that's going to be about 1.
Gotcha. Cool. Yes, you are the percent girl. It's true.
I do like percents. Okay, you ready for another one?
Yep.
What if I asked you 45/46?
Holy cow.
That one's
Okay.
hard to say. 45/46 divided by 2.
Okay, so the fraction 45 out of
40
46
mhm.
divided by
Divided
2.
by 2. Yep.
All right, so
Here's your
fraction.
choices.
Oh, that's right. Choices.
You need
Okay.
your choices. Yep.
Yeah.
0, 1/4, 1/2, 3/4.
Well, of course, the answers are all fractions. Okay, so I could choose to say to myself, well, it's fractions, so I could reach into rote memory and do a bunch of steps, or I could just say to myself, I've got something divided by 2. Well, that's just like cutting it in half. Bam. So 45/46 is almost 1. It is hard to say. And so I could just think about 1, a little bit less than 1. Cut in half is about a half. So I'm saying a half, 1/2.
Nicely
What do you
done.
think?
Yeah.
Would you think? Would you think about it any other?
No, I thought
way?
about it the same way, actually.
All right, there we go. Okay, cool.
All right,
Bring it
let's do
on.
another.
Yep.
All right, here we go.
Okay.
5,003
5,003
minus 0.5.
minus 0.5.
Right.
Okay, is this
ready for
where
choices?
choices. Yeah. Okay.
Right. And so
Yeah.
I don't know that we mentioned, but when you show kids, as close as it gets, when you experience this routine, I have this question for you. Do you put the problem and the solutions all up at once, or do you put them the question and then the answer choices separately?
No, I do just what you did, which is not let me start thinking about it until I see my answer choices.
Oh.
Yeah.
Oh, okay.
Yeah. And there's a pedagogical reason for that because I'm trying to not have kids just do the computation. I want to give them those choices so that they have this sort of sense of, oh, I could reason about those choices without just like starting to do a bunch of steps. And y'all, we want to train kids this way for when they take stupid high stakes tests like ACTs and SATs. And now you know how I feel about those tests. Because we want them to look at the question and the answers before they just knee jerk start doing a bunch of steps or trying to remember a formula that somebody gave them before, but not even before. Instead of we really don't want them trying to like reach into rote memory. We want them just reasoning about what's happening. So we can sort of start that here. So if you were to show me this in class, I would see the problem 5,003 minus 0.5, but I would also see the answer choices at the same time. And you're about to give those to me.
Yes. Okay. Here we go. 5,000.
Okay.
5,001.
Okay.
1,000.
Okay.
4,999.
4,999. Okay, so let's see. I'm noting that the 5,000 and the 5,001 and the 4,999 are all really close together, which means I might have to get actually fairly close with this answer. I can't just say it's about 5,000 because, I mean, is it really about 5,000? I mean, so I'm looking at 5,003 and I'm thinking it's about 5,000 and I'm subtracting 1/2, 0.5. So that's not very much at all. I could say, well, that's about 5,000. But I've got 3 numbers that are around 5,000. So I think I better get a little bit more picky. So 5,003 minus 1/2 doesn't even get me to 5,002. So the largest choice you gave me was 5,001. So I'm calling it 5,001 is the best answer. I'm smiling a little bit at your choice of 1,000 because I've seen for sure students where they would take a problem like this and they would line up the numbers. And so it would be 5,003 minus 5. but
Mm-hmm.
it would look like 5,000 and they would end up with like more like 1,000 or something. So
Yeah.
yeah,
Yeah.
absolutely.
Yeah.
Good answer choice.
I could absolutely see this routine being something like, how would somebody get one of the other three choices?
Oh, nice
Yeah. Yeah.
iteration. That could be,
Mm-hmm.
yeah.
All
So,
right.
all right.
Last one.
So you,
Ready?
yep, go.
All right. 992 plus zero point 0.3.
992 plus 0.3. So you just really want me to sort of think about these relationships. What are
Yep.
my answer choices?
993,
Okay.
995,
Okay.
1000, 1200.
1,200. Okay. So let's see. Um, yeah, this would be good to maybe I'll have you do that. You can talk about how all the answer choices.
Oh, gosh. Okay.
Okay. So 992 plus something that is not very big at all, like it's less than one half. It's less than one. It's less than one half. Is just about. I was about to say pert near. It's pert near 900. That's a joke on Texas. That's 992 plus just a little bit is about 992. And my choices is it closer to 993 or 995? Well, I didn't even make it up to 993, so I think that's got to be my choice because it won't be as big as 995. All right, so Kim, the 993 and 995 I think makes sense to me.
Oh,
Well,
but the 992, if somebody wasn't looking carefully, that's 3/10, and they called it
oh,
3,
they called it
then
3.
902 plus 3, right? That's a pretty common error.
Nice.
That would be
Okay, okay,
995.
okay.
I'm thinking again, if you're not thinking about place value,
Hmm.
then you're thinking 900 plus 300. You're lining that zero point 0.3 up underneath the 900. You're going to
Hmm.
get something close to 1200.
Bam. Yep.
Yeah.
Yep. And I'm also thinking the 1,000 comes from, if you just look at 992 and you say, well, that's almost 1,000,
Yeah.
then you can sort of round up to the 1,000. Cool. All right. We like as close as it gets. It can help students get out of the mode of this knee-jerk reaction to that they can really think and reason. Now, so Kim, I got to tell you, when we were thinking about doing this podcast episode, we were looking at problems in my book, the book that I wrote, Lessons and Activities for Building Powerful Numeracy. And I realized just how much I've grown. Like I was looking at some of the questions like, those are too easy. And you were like, no. And I was like, Kim, those are too easy. And you're like, Pam, you've grown a lot. It was really interesting to me to feel that growth. I mean, I wrote the book,
That's
I
so
wrote these
great.
problems, and now it's kind of cool. So we can all learn and grow more and more as we do
Yeah.
more and more real math.
Yeah. So where can we find these, Pam? If people want to do as close as it gets, I'm going to tell you where you can find them. You can check them out on our website. We have an instructional hub that has problems that you can do. That would be found at bit.ly/instruct route. That is bit.ly/instructrout.
It's like instructional routine. That's
Yeah.
what I was thinking. Don't make fun of my Bitly link.
Instruct
Sorry.
route.
We'll definitely put that link in the show notes. But y'all, you could just go to the website, mathisfigureoutable.com, go to Learn Now. And under Learn Now, you'll see instructional routines. And you can see more than just this one. But for sure, this one's there. If you go to the instructional routine page, you'll see as close as it gets. And then lots of examples that we have put out already that you can just flat out take off the website, use with your classes. You can also click on each individual one and go see what people have said on social media about those particular, each particular question with its answer. So we like that routine. So if you want to learn more mathematics and refine your math teaching so that you and your students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.